Good afternoon, everyone. Let's give you a kind of list of things we're going to do. Some will be a recap, but yesterday things kind of got a little bit distracted because of the power thing. I do have a full video, so if you missed some of yesterday's, you can go back and watch it. It's in Canvas. But let's start with, my first thing is, let's look at finding z-scores. So today we're going to look at the normal distribution. So my goal is, if I can, to finish chapter 8, the normal distribution today. Right. Now, the formula for z-scores, since we are looking at populations, the formula is going to be data, take away the mean, divided by the standard deviation. So if I tell you that the mean of a population is 110, and that the standard deviation is 50, and you're given a data point of 123, then the z-score will simply be 123 the data, take away the mean, and divided by 50. And so you'd go 123, take away 110, and then divide by 50, and you get an answer 0.26. Are we comfortable with z-scores? Right, data, take away the mean, divided by standard deviation. So we'll kind of call that done. The second thing we're going to look at now then is we're going to look at using SALT. So that's the program that we use for statistics inside Web of Science, to find probabilities. So a little background before we start using SALT. We imagine that we have the normal distribution. In fact, not just the normal distribution, let's do the standard normal distribution. Now, that's the one that uses the z-score. So the mean for a standard normal distribution is 0, and its sigma, its standard deviation is 1. So if you were drawing a sketch, it would look something like this. Okay, so far so good. Right, now, the types of questions that you're going to be asked, at least in the early half of the homework, are going to be things that look like this. You will know that it's a standard normal distribution because we tend to use the letter Z because of z-score, I'm assuming, right? And here are the 3 typical types of z-score probabilities. So we're going to find what's the probability that you get a z-score bigger than 1.2. Now, this entire shape has an area of 1. And the reason they are designed in that way is that if you wanted to know the probability that you get a z-score greater than or equal to 1.2, it's essentially the area of here. And SALT calculates that area for us. So all we need to do is type in the right place, of course, how that works. So I'm now going to nip over to SALT and Web of Science at least, and show you how we would do that. So I'm just picking a random SALT button. Let's pick this one. If I bring this guy over here, maybe shrink it up a little bit. The first question I had, although you can't see it anymore, is Z greater than or equal to 1.2. So you've got a normal distribution. Make sure that it's in this heading, distribution calculators. Normal distribution, which is the default, which is good. Go away picture. Mean of 0, standard deviation of 1. And I wanted greater than. So right tail is greater than. Can you see the little shading? Very similar to the one I had. And you go over here and you type in whatever the number was, and it was 1.2. So this is going to give you the chances it's greater than 1.2, and the answer is this guy at the bottom. And I'm just going to round these fellas off to 2 decimal places. So that becomes 0.12. Now, the next question you can't see was Z less than or equal to 1.8. So if you want less than, you hit left tail and you turn this number into, well, you want less than 1.8. So you type in 1.8. And there's your answer. It's about what? 96, 0.96. And if you want to know what's the probability that you get a Z score between negative 1.3 and 2.1, that's what my next question is, use the between button. And it's between negative 1.3 to, on this side, 2.1. Do you see how you do a between? And your answer, like all the others, is down here, and that rounds off to 0.89. Are you comfortable that it's kind of obvious, it's pretty straightforward where you put your numbers to get a bigger than, a less than, or a between, right? If you want to do a less than, left tail. If you want to do a more than, right tail. If you want to do a between two numbers, use the between. Are we good with that? Okay, so let me return back to our white screen. And there's the answers, at least to 2 decimal places. If I turn them into percentages, because my brain just works better with percentages. The chances that you have a Z score bigger than 1.2 is only going to happen about 12% of the time. So that's pretty unusual, right? It's not going to happen that much. The chance that you get a Z score less than 1.8 isn't a really big number, so that's going to happen a lot. And the chances you get between this number and this number is 89%, and that's very common as well. So when you're finding the probability of getting a Z score greater than, less than, or between, you're basically saying to yourself, how likely is it that I get that Z score? And the answer is, depending on the question, not a lot or very common. Are we good with that? Do I need to do another one, or do you feel comfortable about using SALT to do these 3 kinds of questions? Are we good? Okay, I got a nod. I'm calling that good. So let's move on to these fellas. And 3 and 4 are actually together, but I've separated them as just using numbers to now we have stories. So let's do the just using numbers ones first. We're now going to do the normal distribution again. If you don't put the word standard in front of it, it just means it's any normal distribution. So this is just one of many. Suppose I have a mean of 50. That means that guy right in there is 50. And let's suppose the population is 5. Then you can imagine what the distribution of, I don't know, animals' weights are. I suppose this is some kind of animal. And you're going to be asked the same kinds of questions that we were asked here. Right? But you're going to be asked bigger than, less than, or between. Right? So let me make up my own. You might be asked, what's the chances that your data, and we call it X when it's normal, and we call it Z when it's standard normal, right? So that's just a convention. Z or X. X is much more common because you're in real world, aren't you going to deal with 45s and hundreds, right? You're not going to be dealing with 0, 1, 2, 3s very often. So what's the chance that it is bigger than 56. What's the chance that it's less than 41? And what's the chance that it's between 60 and let's say 39? Would you agree these are very similar to the 3 questions we just did a minute ago? The main difference is that the mean and standard deviation have changed. They're no longer 0 and 1. That's what you get when it's a Z-score, a standard normal. In this world, the mean and standard deviation keep changing depending on the story, right? So we can do that. I've got these numbers, so I'm going to eventually, if I can click on the button, come on. Darn it, it's a pain in the butt, that thing. Right, and let's show you how to use SALT. Right, we're on the normal distribution. You go to the mean and you change it, in this case, to 50. And you do a standard deviation, in this case it was 5. And I want X greater than or equal to 56. Okay, X greater than or equal to 56. Which one of these guys do you use for greater than?
Right tail.
Right tail.
Agreed. Now, once you've done that, can't you rub this number out and put in, well, 56? And isn't there a little picture to kind of visualize? So you know it's the right direction. And the answer here is about 0.12. The next question was less than or equal to 41. Okay, which one of those fours is going to be the less than?
Left tail.
Right. The way it just helps me. Left, less, L and L, right? Less, left, right? Because if you remember, that one isn't the other one right, you know? So less than, so I want left tail, less than 41. And the answer I get is about 0.04 if you round it off to 2 decimal places at least. I'm not going to ask you which one to use for the between, because isn't the between kind of obvious just because its name says it. And I want to get between 39 and 60. So the little guy goes in the left, 39, and the big guy goes in the right, which in this case was 60. And the answer is 96, 0.96. So if you get a question with means and standard deviations given, and you're asked to find these things, are you comfortable about how you would do it in SALT? I'll do it to 2, but maybe it's 3, maybe it's 4. Sometimes because they just decide to, they might say give the answers as percentages if they did, you know. So, you know, be on the lookout, because they have done that before, haven't they? Done one question where it was a decimal, they said proportion, and then the next question, almost the same question virtually, but it's a percentage. And sometimes if you don't, you know, if you're not reading carefully, you can miss that. Do you need to see another one of these, or you feel comfortable about using SALT if I tell you the mean and standard deviation and ask you one of these 3 guys? We feel good? You want to see another one? I see you nod again. This is going really fast. The next bit won't, but that's fine because it's not meant to go slow. Everything that we've been doing right now has just been button pressing, hasn't it? You hit SALT, you put numbers in various boxes, and you read an answer off. So let's put that into a practical context, right? Let's suppose that I had an exam, right? Really big exam. And in this exam, the population, because it's everybody, the mean in this exam was 75, and the standard deviation was 6. And I would like to know, what's the probability that somebody in my class scores above 90, right? What's the probability that I randomly pick somebody in my class and gets a score greater than or equal to 90? When we like to know that, right? Based on that raw data and the fact that we'll assume that the data is normally distributed, right? So there's 75. 90 is kind of somewhere over here, isn't it? Would you agree it's probably going to be quite small? But I want to put a number on quite small. So what you do is you nip over to Weber sign. And I want to know greater than, right? And the mean in my class was 75. And the standard deviation for my class was 6. And I want to know what's the chances that you get 90? Oh dear. Would you agree that the answer is very, very small? 0.006 to 3 decimal places. And I'm going to look at that and I'm going to think to myself, I think that exam was kind of hard. In fact, since I like percentages, isn't that less than 1% of the class? Which means, wouldn't we be lucky if one person in the class actually got that score? I might also be interested in what percentage of the class, say, got less than 70. And while I'm at it, that way I can do 2 questions at once. And maybe I want to get a feel for the middle of the class. What percentage of the class kind of got that score? Right. So I just return back to salt, and now I can try these ones. Let's find less than 70. So the only thing I need to change is that. And 20% of the class, right, 0.20. Well, let's put it to 3 decimal places, which is about 20.2%. And what about the betweens? What's the middle chunk look like? So students in the range 70 up to 80. What percentage of my students got that range? And the answer is about 0.595. Can I basically find anything I want now? Can I find percentage bigger than 82? Percentage of the students, right, less than 55, just by using salt? It's a very powerful tool that if your data is normally distributed and all you know is the mean and standard deviation, you pretty much know everything that you need to know. Agreed? So I'm now going to show you a different type of question, which is percentiles. And then once we've done that, we're going to just look at the homework questions, the later homework questions, and maybe do some of those. But let's do this one, and I'm going to connect it to that. But before we do that, actually, probably should do it on your piece of paper. Let's tell you what a percentile means. If you've ever done a kind of standardized exam like SAT, for instance, you'll get a score like, I don't know, I got 520 in my English. And if you look hard enough, won't they tell you your percentile? And your percentile is a special number. So I'll give you an example of what a 7, suppose I was in the 70th percentile in, say, an SAT exam, right? I don't care what the score is. I just want to know, what does a 70th percentile tell me? Well, the SATs are very much normally distributed, and 70th percentile would be a score about here, right? whatever that score is. But what it tells us is that it tells me that the score I got was better than 70% of the people who took the SAT. Doesn't that give you a good idea of how good you are, right? Now, you can think of percentiles in two ways. That's the way you should consider it. 70% of the people got my score or less, but can't you sometimes turn it on its head and say it something like this? I'm in the top 30%. Isn't that the same information, just looking at maybe in a more optimistic way, right? I'm in the top 30%. So we would like to know what score you are, right? So this is a score. So when somebody says the 70th percentile was 180, what they meant was I got 180 in this test compared to everybody else, right? And my 180 puts me, right? 70% of the people did that score or worse, right? So the percentile is a score, right? It's a number from the x-axis. So let's do IQs. There's an IQ, the mean is 100, and the standard deviation is 15. And I got my IQ test, and since it's my question, I'm doing it. And I got an IQ test, and it told me I was in the 95th percentile. And what we want to know is, what is my IQ? So if you try to think of this visually, there is 100, right? 115, 130, right? 145, right? Somewhere, isn't that 95% and that's the other 5%, right? What kind of IQ would I need to be in the 95th percentile? And we can do that with SALT. And let's show you how it works. So to calculate a percentile, you can just use SALT. So this question had a mean of 100 and a standard deviation of 15. Do you see you use the same table, the same guy? So far, so good. When you're doing percentiles, will you please use the left tail and only the left tail, right? So if it's a percentile question. Now, normally you put a number in here and the answer comes out there, right? What you do in this case is you switch it. You put the answer here. So if I'm going to be in the 95th percentile, you rub this out and you put 0.95. Isn't that 95 as a decimal? And do you see that the score, that's my IQ score, 124.6. So I would write that down to a nearest whole number as 125. Okay. Well, since I've got this one set up, 99th percentile, right? Wouldn't that put you in the top 1% of the IQs of the world, right? What kind of IQ do you need to be in the top 99%? Maybe I could make this a little bit bigger. We'll lose the picture, but at least we'll see the data. Right. Wow. Do you know you only need to get 135 to be in the top 1% of everybody? What about 99.9 percentile? Right, that's what, the top 0.1%. Do you see that you would only need to have an IQ of 146? So if you meet someone and they say, oh yeah, my IQ is 160, there are two assumptions that you're going to make. The first assumption is that they're lying to you, or you've just met the most intelligent IQ person in the world. And you'll have to base that on the person that you've just met, right? Do they look like a liar? Or do they look like a genius? Not only a genius, but you know, the genius amongst the geniuses. Do you like the percentile idea? Do you see it's not that more difficult? You're just using the information in reverse order. Don't normally we put a number here and this is my answer. But when you do percentiles, you kind of know what the answer is and you're trying to find out what number would give you that answer. So kind of turning the information on its head. Are we good? Things seem to be going good today. Am I picking up the wrong vibes or are things going good today? They are, right. So I have no idea where I am now. Let's look at, oh, thank you, John, thumbs up. Is this much better than chapter 7, the probability stuff? A lot of thumbs up on that one, okay. So that's not what I want. God, I'm getting worse. Let's try this again. Here we are. Okay, so let's, I'm gonna have to shrink this. Do I? Yeah, I'll keep it the way it is right now. Let's just talk through the types of questions because we've kind of covered everything. These are finding z-scores. These are finding z-scores, right? We've covered that. That was number 1 in my list. Isn't this using SALT to get the probability that your z-score is less than 1.96? So I want you to think of this question as being the probability that you get z less than the number they just gave you, right? Does that make more sense when you put the thing together? So that's essentially the second thing we did today. Isn't this, here is the mean, here is the standard deviation. Use that's number 3. Use SALT. There's some more Z's. When I do SALT on this one, do you notice that it says Z? Do you notice in this one it said X? When it said X, didn't they tell you the mean to use and the standard deviation to use? But when the questions just say Z, what's the mean and standard deviation you automatically use when they use Z?
0 and
A
1.
mean of 0.
Yeah, mean is 0, standard deviation is 1. So, just in case you look at that question, you think, I can't do it. I don't know the mean and standard deviation. Well, okay, they haven't told you, but isn't the implication because they use Z that you assume that it's 0 and 1 because it will be? There's some more bigger than and less than. There's some of the ones where we're returning to X's, but when they do X, they tell you the mean and they tell you the standard deviation. There's some more of those guys. Same basically as question 7. So let's do some word stories now, right? Questions that actually have, a story behind them. So I'm going to write some stuff down because I can't keep it in my head. Suppose that the amount a student at college spends on textbooks has a mean of 330. Do you see mu equals 330, right? That's the mean. And the standard deviation sigma is 110. Are we comfortable about those symbols and which one means the mean and which of those means the population standard deviation? And 4 decimal places. Got to remember that. And the first question says, what's the probability that a random selected student spends less than 396? Now, you don't write this down in the box, but I'm putting it in just so you can see how it would be written. Less than 396. Technically less than or equal to, but we're not going to argue over the equals to sign because it doesn't change the answer, right? We happy with that? Less than means this guy. More than 220. Would you agree that X greater than 220 is how that would look if you did it more algebraically? And the funny one is the between one, and that would be 220 That's mathematically how you write down between. Okay. Now, the right answer, the real answers are going to be the numbers that you get from salt, but they're kind of there to help me, and I'm writing them down again because they'll disappear in a minute. Okay, so I'm going to hit salt. Here we go. And I'll bring this guy over to the front. And it's a normal distribution. And the mean was 330. And the standard deviation was 110. And the first one was less than 396, so left tail. And 396. And so the answer would be that guy to 4 decimal places. So it would be equal to that guy to 4 decimal places. So that rounds up to 8. We're comfortable with how we did that? Right? Show the picture again. Normal distribution. Gotcha. Mean of 330. Standard deviation of 10, a left tail because we're looking for a lesser. Now the next one is going to be right tailed, and we're looking for more than 220. And that ends up being this guy. So we'll go in here and we'll put this guy in. And let's rub that out so we can see the whole thing. And let's rub that out. What's wrong with answer B?
Too many decimals.
Yeah. And in this case, won't you just lose the 4? It doesn't change anything. It rounds down. And then you get the last one. So here we go. And last one is going to be 220 to 396. So that's going to be a between. $220 on the small side. Oops, hit the wrong button there. Wrong box, I should say. 220 on the small side. And 396 on the big side. And the answer is that guy. And if you round that off, that goes a 1. So if you were at this college, the chances are that 72, almost 73% of my students would be spending less than $396. 84% of my students would be spending more than 220. And about 56, 57% of my students would be spending this amount. And so you can imagine that we can actually find out what percentage of our students pay any particular given value, right? Can I find out what percentage of my students spend between $300 and $400, right? Can I do that? Or 150 to 250, and I could do that. It's bad at college, but can you trust me, it's worse at university. Textbooks are scarily expensive. I have recollections. To give you an example, it's probably not allowed to do today, but it happened at my university. The professor that I got my math class from, right? One of my math classes from one of my algebra classes it was, actually wrote the textbook that was being used. I think that's a conflict of interest. But evidently when I went to university, it wasn't. I don't know if it's a conflict of interest today. Has anybody said, oh, I'm at university and the guy that I'm getting taught by is actually the guy who wrote the book?
One of my friends is going to grad school and she ran into that, but he gave out his textbooks for free because he was getting ripped off by the people who were selling his textbooks.
Oh, okay, so that wasn't so bad. Yeah, you can imagine. I would imagine that there'd be a conflict of interest, but what do I know? I'm not convinced by this, but I think it's only, to be fair, I should tell you the explanation that I've been told for why textbooks are so expensive. It's not that they cost so much to make, because they're actually mostly in PDFs now as well, aren't they? You can get them in non-physical formats. It's the fact that many textbooks don't actually sell that many books. Right now, the further up the food chain you go, right? So if you're getting a postgraduate book and it's on the psychology of workforce problems, right? Some really obscure side issue in psychology. Do you know you'll be lucky if you sell 200 books? Because there's only probably a couple of hundred people who are even doing that course at any given time. And because that, the overheads are really high, because the person that writes that book, doesn't he still put in the same amount of time that somebody who writes a book that 1 million are made? And so I'm not sure that I believe that, although I think there's some truth in it. I also believe that they just rip you off, because if you have to take the class and that's a textbook, don't you have to take the class and that's the textbook, right? You're kind of, there's no way out, right? You got to get the textbook. And I do feel your pain. I mean, we're doing WebAssign right now. You know, you can't take this class unless you do WebAssign, right? You got to pay for it. I mean, thankfully, WebAssign's not as extortionate as some of the things you might have bought. Just to share a few seconds left, and then I'll do our last topic. What's the worst, most expensive textbook you've had to buy at Olympic College?
My chemistry textbook.
What, off the top of your head, can you remember its cost?
$356.
Ow, painful.
Taxation. It was almost 500.
Right. I mean, okay, you can sell it back and get some of your money, but you won't get all of it back, right?
Not
Oh, no,
taxation.
I rented it.
Not
and
even
also had to
taxation.
pay for a lab on top of it.
Tax rules change almost every year.
Oh,
So
so
it's rewritten almost every year.
it's good and then it's no good. Right. Okay. Well, the last question that we are going to be looking at is one that involves us doing percentiles. So let me do it. It's question 12. Assume that the total cholesterol levels. Oh, can you see this, by the way? Because I'm not even sure where we are now. Are you looking at question 12 on the screen?
Yes.
Okay. So assume that the total cholesterol level of 30 to 39-year-olds has been calculated. It's normally distributed, and the mean level is 200, and that the standard deviation is 32. Find the cholesterol value such that 20% of the women in this age group have a lower cholesterol value. That is just another way of saying the 20th percentile, right? I'm in the bottom 20%. So I'll just keep a note of the numbers. The mean is 200. The standard deviation is 32. By the way, they're only one of these questions, so that's it. So here it goes. I'll bring it over. Normal distributed. The mean is 200 in this story. And that the standard deviation is 32 in this story. And we want to be, remember, left tail in this question at least. And we want it to be 20th percentile, right? And the nearest whole number, it's that guy, but let's just, didn't mean to do that. I meant to copy it, but somehow I deleted it, right? So I'm taking that answer. Copy and paste is quite good, isn't it? It means that you don't accidentally, type the wrong number in. For me, it is. And they want round your answer to 2 decimal places. So to 2 decimal places, that 6 goes up to a 7. Now, what's the percentile ranking? We call that guy the 20th percentile. So the second answer is easy. And okay, we did it. We finished. I got my goal. I'm happy.